Chapter 5 is going to focus on heat and temperature.
So temperature is a measurement of the heat content of a particular substance. So it's basically what we measure with a thermometer, whether we're measuring our own body temperature or we're measuring the temperature of a liquid. So the human sense of hot and cold cannot be determined just by temperature alone. Conduction and humidity are going to affect the human sense of hot and cold as well. So if you think about going outside and you're looking at the forecast and it says, okay, it's going to be 80 degrees. Not so bad, right? But an 80-degree day with humidity is going to feel a lot hotter to us than if there was no humidity. So even though the temperature might be the same as somewhere else, with a dry heat, the way we perceive it really depends upon several factors. So looking at temperature, we're going to do some temperature conversions. We're going to talk about Fahrenheit first. And Fahrenheit is the temperature that we usually use here in the US. It was developed by Daniel Fahrenheit, named after him obviously. What he did was he placed a mercury thermometer in an ice bath, and he realized that at 32 degrees Fahrenheit, that was the temperature at which water freezes. He then also measured the temperature of water boiling, and it was 212 degrees at which water boils. So these two values you're going to want to remember. 32 degrees Fahrenheit for water freezing and 212 degrees Fahrenheit for water boiling. Looking at degrees Celsius. So this is the common unit of measurement for temperature in most other parts of the world. And Anders Celsius actually developed this scale. So he proposed a scale of degrees Celsius to try to make it a little bit easier. What I mean by that is you'll notice that the freezing point for water in degrees Celsius is 0. So this is an easy number to remember, much more easy than 32 with Fahrenheit scale. For boiling water, 100 degrees. Okay, so the reason for the degree sign is because they're basically making these scales based off of a certain degree. So here are some temperature conversion calculations that we're going to be using to convert between Fahrenheit and Celsius. So these equations will also be present on your equation sheet. So if you are converting between Fahrenheit and Celsius, you'll want to make sure to use the equation where Celsius is equal to, because Celsius is what you're solving for. When you use this equation, in the numerator we have F minus 32. So you're going to take the Fahrenheit value given to you in the word problem and subtract 32 from it. But notice there are parentheses around F minus 32. Make sure you have that top portion in parentheses, because if you do not, it will divide by 1.8 before it does the subtraction due to orders of operations. Looking at the next equation going from Celsius to Fahrenheit. For this one, when you are looking for Fahrenheit, you want to use the equation where Fahrenheit is equal to. And in this case, it's really just the previous equation rearranged. And you're taking 1.8 times the degrees Celsius and then adding 32 to it. The parentheses aren't necessary as it will do the multiplication before it does the addition. One unit of measurement used for temperature that you might not have heard of is Kelvin, represented by the letter K. Notice there is no degree sign when we talk about Kelvin, because it's an absolute scale. It doesn't have a degree measurement to it. It's named after Lord Kelvin. And what Kelvin is, it's the SI unit for temperature. So when we talk about SI units, back in chapter 1, it was the international system of units that was decided upon in the sharing of information between the science and mathematical fields. Kelvin being an absolute temperature scale, the degrees aren't used. So what that means is you can't go below 0 Kelvin. So 0 Kelvin is the absolute lowest possible achievable temperature. 0 Kelvin is also referred to as absolute zero because of this. It is the temperature at which all molecules and all atoms quit moving. So if we could actually reach 0 Kelvin, life on Earth would perish. Nothing would survive. It's that cold. To calculate Kelvin, you simply take the degrees Celsius and add 273 to it. Notice I don't have a way shown here to calculate Kelvin directly from Fahrenheit. So if you are given degrees Fahrenheit and you need to get to Kelvin, you're going to have to first calculate the degrees Celsius. Once you have the degrees Celsius, you can then insert that in the following equation to get to Kelvin.